Okay, you ready, John?
Yep, starting.
Hi. My speech today is a commemorative speech, and I want to talk about the 20th anniversary of the Hubble Space Telescope, which turned 20 a few weeks ago. When I originally wrote this speech, it was the same weekend. Now it's a few weeks ago. Which turning 20 is a pretty impressive accomplishment for a device that was designed in 1979, and when originally designed was only supposed to last 15 years. And even that life would require that it be brought down from orbit and refurbished every 5 years. So here it is, it's been in orbit for over 20 years, still running. It has required a little servicing along the way. Of course, you know, it was a different world back when the Space Telescope was designed. It was thought that they'd be able to come and go from orbit really easily because it was designed in 1979, and a couple years later in 1981, the Space Shuttle was going to launch and make getting back and forth to space just like taking a bus down the block, no big deal. There were delays after the design, correct various things. They eventually decided on a launch date of 1986 instead of the original launch date of 1983. Unfortunately, January 1986, the Challenger disaster came, pushed everything back quite a ways. So the telescope did not make it into orbit until April 24th, 1990, aboard the Space Shuttle. And everybody was real happy, but the happiness didn't last that long because they took the first pictures. Let's see, speaking of pictures, I have a few here. That is the Hubble Space Telescope, and that is the Hubble Space Telescope going into orbit in 1990. And that is the first picture of one star. Oops. They ground the mirror for the telescope wrong. Fortunately, they ground it wrong really accurately. So they were able to figure out the error, and they were able to make corrective optics, almost like eyeglasses for the telescope. And so they started a series of servicing missions to send the shuttle up to fix things and make them better. And if you're wondering about the mirror, this is actually the backup mirror, which was ground by Kodak, and it doesn't have the silvering for the mirror on it, so it doesn't really look much like a mirror, but it was actually ground correctly. But it's the one they left on the ground. This is after the first servicing mission, where they went up and they installed the corrective optics. The picture on the left is the kind of picture the Hubble was taking before the correction, and that's the same picture on the right after the correction. That's a little bit nicer. That servicing mission was the first of many. There were a lot of things that got done to Hubble over time. The second servicing mission in 1997 added 2 new instruments and added larger data storage so they could keep track of more of the pictures before they had to send them down to the ground. And the third mission, or what they call Mission 3A, actually the numbering is kind of funny, in 1999 replaced all 6 gyroscopes to help the telescope maintain more accurate pointing, and it installed a new computer, a 25 megahertz radiation-hardened 486 with a whopping 2 megabytes of memory. I know it seems pretty small nowadays, but at the time that was pretty fancy. And the radiation-hardened part, that's not trivial. You can make a big, fast computer. Making one that can sit up in space and get blasted by cosmic rays all the time and still work, not so easy. The next mission, which I would say is the 4th mission, but they call it Mission 3B, in 2002, replaced the last original instrument. So at this point, all of the instruments had their own corrective optics, and COSTAR, which is the corrective optics package, wasn't needed anymore, so they were actually able to replace it with another instrument. It had actually replaced one of the original instruments that they sort of sacrificed in order to have a place to put the corrective optics. And they installed new solar panels that were smaller, but actually generated more power, which were actually some panels that had been built for the Iridium satellites. Their design just worked out and was economical to do. The last servicing mission, which happened last year, was originally planned for October of 2008, but in September of 2008 there was a failure of at least one major component on the telescope, and so they decided they better go ahead and build a replacement for that and reschedule the servicing mission so they could replace that too. It was actually one of the control systems. So in May of 2009, they had the last servicing mission, called Servicing Mission 4, even though it was the 5th servicing mission. And they went up and they replaced lots of stuff. They put in 2 new instruments, and they replaced a lot of the parts, including a brand new set of batteries, which, considering the original batteries at this point were 13 years past their original design life, this was probably a good thing. And the telescope resumed regular operations in September of '09 and is expected to be good through 2014. You know, nobody really knows exactly how long it'll last, but it's hoped that it'll last at least that long, and maybe it'll be longer. And of course, this long repair history is kind of noteworthy because the telescope has been up there so long. But it's not really about the repairs, it's about the science that it's done. And that's everything from refining estimates of the age of the universe to looking at distant supernova, amazing pictures of things like what are called the pillars of creation that I'll show you in a minute, or pictures of the Shoemaker-Levy 9 comet impacting Jupiter. 2 pictures that are some of the really most amazing are called the deep field and the ultra deep field. And these were pictures that were made out of a composite of dozens of exposures with total exposure time of up to 1 million seconds, looking at just a tiny, tiny, really dark patch of the sky to look at things that are really, really far away. With Hubble has contributed so much to science, there are actually over 8,000 papers based on Hubble data that are in peer-reviewed journals. And papers that contain Hubble data are twice as likely to be cited by other papers as papers without Hubble data in astronomical fields. The really cool thing, though, is that anybody can apply for time on the Hubble. It doesn't matter what university you're affiliated with, what country you're from. Even amateur astronomers have actually applied for and been granted time on the Hubble. Not many, but a few. The data is usually embargoed for a year for the principal investigator, and then it's put up on the website of the Hubble Space Telescope Institute, and anybody can look at it, including us. And we can't know how long the telescope's going to last, but we can hope it'll be a long time, more anniversaries and more discoveries. And I also had a few more pictures here I wanted to show you. This is from Servicing Mission 1, where they first went up and installed the package to fix the images. And this is when they released it after the last servicing mission, which was number 4 or number 5, depending on how you count. And when I was talking about the pillars of creation, this is really like a place where stars are actually being born in these giant dust clouds. And this image, when it took, this is what's called an Einstein ring. The image on the right is kind of a blow-up. This is actually the light from a distant star being focused by the gravity of a star in front of it into this ring. Think of it almost like a rainbow in space, except created by gravity instead of by water. And then this picture actually takes a minute to load because it's so huge. This is a reduced copy of the Hubble Ultra Deep Field. And all of these galaxies and other distant objects are in a patch of sky that is a tiny fraction of the size of the moon in the sky. It's actually like 0.02 arc seconds, if I remember correctly. And this image actually, NASA actually took a poll on what things people wanted the Hubble to take a picture of, and the Horsehead Nebula came out on top. So whether or not it was of any particular astronomical value, they took the Hubble and they took a nice picture of the Horsehead Nebula for everybody to look at. And that's all the pictures I have for you. Thank you very much.